Here's another instructional video using Desmos.com's geometry tool. Okay, so here it is. Let's turn on your grid for this. There we go. I'm going to put some axes on here using lines. Okay, axes on here using lines. So, oops, it didn't go. I'm going to be strategic about this one. And let's see, how about another one here? Okay, because in this one, we're going to do a dilation. Okay, so what we're going to do is I'm going to put some points on here. Let's make a quadrilateral. Here we go. There, that looks kind of like a, it's not, that's some random quadrilateral. There we go. Okay, we're going to connect each of these points with some segments. Okay, and I do it this way because I do not want the polygon here to be shaded. So if you use the polygon tool, it will be shaded. So we're going to label each of these points, A and B and C and D for my quadrilateral, that we're going to dilate by a scale factor of 1/2. Okay, so that's what's going to happen. This video, we are dilating this by a scale factor of 1/2. Dilation by scale factor of 1/2. Okay, that means that each of these points around the origin is where our center of dilation is going to be also. That's important to know. So our origin is our center of dilation. Each of these points is going to get half as far away, right? Or twice as close, maybe, half as large as it is now. Okay, so this is how we're going to do our dilation. We need to count. That's basically what we need to do is count. So how far away is point A from this point? So it's 1, 2, 3, 4, 5, 6 units to the right, and 1, 2, 3, 4, 5, 6, 7, 8 units vertically. Okay, so 6 over 8 up. Half of that is going to be 3 over 4 up. So we're going to put a point right here at 3 over 4 up. Okay, B is 6, 7, 8, 9, 10, 11, 12, 13. 13 to the right. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And 1, 2, 3, 4, 5, 6, 7. So half of 13 is 6.5. 1, 2, 3, 4, 5, 6.5. And half of 7 is 3.5. So point B is going to end up right there. Okay, C is at 12.1, so it's going to end up at 6.1/2 right there. And D is at 6.3, so that's going to end up at 3 and 1.1/2. So we put those points on there. Okay, we can connect them all with line segments. Okay, in fact, we can come in here and use our polygon. We probably could have done that first. And made this into a polygon so that it got shaded. Remember, you always shade your image, never the thing you start with, your pre-image. Okay, so there it is shaded. Now we have to label these points. Let's see if it will let me label them. There it is. Label this point. This one came from A, so it's A prime. Right? This point here, this point came from B, so this is B prime. Okay, this point down here came from point C, so it is the translation of C prime, or the dilation of C prime. And this one is point D, if I can ever select it. Come on. And it becomes D prime. Okay, so this is the dilation, the polygon, the quadrilateral. It is a dilation of a scale factor of 1/2 around the origin as your center of dilation. So this is where we're counting from, right? From our original polygon ABCD. Okay, what's kind of neat is if you were to draw a line segment, or let's just do a ray, from the origin right through this point, notice it lines up with both of them. Okay, that's how you can know that you did your dilation right, is if they all line up. Kind of make a three-dimensional. See how D and D prime are in line? And B prime are in line-ish. Okay, and C prime. Okay, of course, these are halves and they're not perfect, so that's why they don't exactly line up. But you can always do that when you have a dilation. Okay, you can draw a line from your center of dilation through these points, and they should line up perfectly. Okay, which means I probably have to pull C down a little bit and B down a little bit, but that's neither here nor there. Okay, so that is a dilation around the origin with a scale factor of 1/2.